Welcome to Star Technology 5G. In today's video I will show you how to display temperature using PIC ADC module. Let's start the video. Please subscribe to the Star Technology 5G and click on the bell icon. Analog to digital converter A/D module. An analog to digital converter is another important peripheral component of a microcontroller. The analog to digital converts an analog input voltage into a digital number so it can be processed by a microcontroller or any other digital system. Because the analog to digital converter is widely used in data acquisition, in recent years an increasing numbers of microcontroller have an on-chip analog to digital converter peripheral. An on-chip analog to digital converter eliminates the need for an external analog to digital converter connection, which leaves more pins for other input-output activities. The PIC16F877 contains 8 analog inputs. They enable the microcontroller to recognize not only whether a pin is driven to logic 0 or 1, 0 or positive 5 volt, but to precisely measure its voltage and convert it into numerical value, digital format. Registers used for ADC. The ADC module has 4 registers. These registers are ADC Control Register 0, ADCON 0, ADC Control Register 1, ADCON 1, ADC Result High Register, ADRESH, ADC Result Low Register, ADRESL, ADCON 0 Register. Here is ADCON 0 register. Bit 7 and 6 ADC-S1, ADC-S0 A/D conversion clock select bits. ADCON 1, ADC-S2 ADCON 0, ADC-S1, ADC-S0. Clock conversion. 0, 0, 0 FOSC divide by 2. 0, 0, 1 FOSC divide by 8. 0, 1, 0 FOSC divide by 32. 0, 1, 1 FRC, clock derived from the internal A/D RC oscillator. 1, 0, 0 FOSC divide by 4. 1, 0, 1 FOSC divide by 16. 1, 1, 0 FOSC divide by 64. 1, 1, 1 FRC, clock derived from the internal A/D RC oscillator. Bit 5 and 3 CHS2, CHS0, analog channel select bits. 0, 0, 0 equals channel 0, AN 0. 0, 0, 1 equals channel 1, AN 1. 0, 1, 0 equals channel 2, AN 2. 0, 1, 1 equals channel 3, AN 3. 1, 0, 0 equals channel 4, AN 4. 1, 0, 1 equals channel 5, AN 5. 1, 1, 0 equals channel 6, AN 6. 1, 1, 1 equals channel 7, AN 7. Bit 2 go over done, A/D conversion status bit. When a done equals 1. 1 equals A/D conversion in progress. 0 equals A/D conversion not in progress. Bit 1 unimplemented, read as 0. Bit 0 A done, A/D on bit. 1 equals A/D converter module is powered up. 0 equals A/D converter module is shut off and consumes no operating current. ADCON 1 register. Here is ADCON 1 register. ADFM, ADC-S2, PCFG3, PCFG2, PCFG1, PCFG0. Bit 7, ADFM, A/D result format select bit. 1 equals right justified. 6 most significant bits of ADRESH are read as 0. 0 equals left justified. 6 least significant bits of ADRESL are read as 0. Bit 6, ADC-S2, A/D conversion clock select bit, ADCON 1 bits in shaded area and in bold. ADCON 1, ADC-S2 ADCON 0, ADC-S1, ADC-S0, clock conversion. 000FOSC divide by 2. 001FOSC divide by 8. 010FOSC divide by 32. 011FRC, clock derived from the internal A over DRC oscillator. 100FOSC divide by 4. 101FOSC divide by 16. 110FOSC divide by 64. 111FRC, clock derived from the internal A over DRC oscillator, bit 5 and 4 unimplemented, read as 0. Bit 3 to 0. PCFG3 to PCFG0. A over D port configuration control bits. ADRESH and ADRESL registers. The result obtained after converting an analog value into digital is a 10-bit number that is to be stored in the ADRESH and ADRESL registers. There are two ways of handling it, left and right justification. If right justification selected, then higher 6 bits of ADRESH register read as 0. An ADRESL register and first 2 bits of ADRESH register hold 10 bits of data. And if left justification selected, then lower 6 bits of ADRESL register read as 0. An ADRESH register and last 2 bits of ADRESL register hold 10 bits of data. Project: How to display temperature using PIC ADC module. In this project, we will connect LM35 analog temperature sensor with a N5 pin of PIC16F877 microcontroller. We will interface LCD with port C of the PIC16F877 microcontroller. The temperature will display every 2 seconds on LCD. Here is the circuit diagram we are using in our project. It is PIC16F877 microcontroller. Pin number 1 is master reset. If we press the switch, it will reset the microcontroller. Port B interfaced with LCD data pins. Pin RC0 interfaced with EN pin of LCD. Pin RC1 interfaced with RW pin of LCD. Pin RC2 interfaced with RS pin of LCD. Pin VSS connect with ground. Pin VDD connect with positive 5 volt. Contrast pin VEE connect with variable. The value of the variable is 1 kilo ohm. LM35 output interfaced with analog input pin RA5. Positive supply interfaced with 5 volts. Negative supply interfaced with ground. Pin numbers 13 and 14 interfaced with an 8 MHz crystal. And 22 PF capacitors connected with the crystal. Pin number 11 and 32 connected with positive 5 volts. Pin number 12 and 31 connected with ground volt. Let's draw this circuit in Proteus. circuit is ready. Now we will write its code in Micro PIC. Here is the window where we can write the code. I already wrote the code, otherwise video gets very long. I will copy the code. And I will paste it here. Now I will define you the code. Hashtag define LCD port B. Define port B as LCD. S bit EN at port CB0. Define enable pin at port C pin RC0. S bit RW at port CB1. Define read write pin at port C pin RC1. S bit RS at port CB2. Define RS pin at port C pin RC2. Void MS delay. Unsigned char time. Define delay function with variable name time. Unsigned char. Y, Z. Define variable name Y and Z. 4. Y equals 0. Y less than time. And increment Y. For loop for delay. 4. Z equals 0. Z less than 254. And increment Z. For loop for delay. Void delay. Unsigned char time. Define delay function with variable name time. Unsigned char. M. Define variable name M. 4. M equals 0. M less than time. And increment M. For loop for delay. Void LCD CMD. Unsigned char X. Define LCD CMD function with variable named X. LCD equals X. Send data to LCD. RS equals 0. RS pin equal to logic 0. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call MS delay function. EN equals 0. EN pin equal to logic 0. Void LCD data. Unsigned char X. Define LCD data function with variable named X. LCD equals X. Send data to LCD. RS equals 1. RS pin equal to logic 1. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call MS delay function. EN equals 0. EN pin equal to logic 0. Void LCD string unsigned char asterisk str. String send function. While asterisk str. Stay in this loop while data not finish. LCD data. Asterisk str plus plus. Send 1 by 1 data to LCD. Void LCD ini void. LCD initialized function. MS delay 250. Call MS delay. We used maximum delay because LCD needs some time to power on. LCD CMD 0x38. Set LCD in 8-bit mode, 2-line mode and 5x10 dots. LCD CMD 0x0C. Set LCD display on. LCD CMD 0x01. That is command for clear LCD. Unsigned int ADC read. Unsigned char channel. ADC read function. ADCon 0 and equals 0x11000101. Clearing the channel selection bits. ADCON 0 or equals channel shift left 3 bits. Setting the required bits. Delay. 2. Acquisition time to charge hold capacitor. ADCON 0.go equals 1. Initializes A or D conversion. While ADCON 0.go. Wait for A over D conversion to complete. Return. ADRESH shift left 8 bits. Plus ADRESL. Add ADRESH and ADRESL register and return result. Void convert display. Int value. This function convert binary code decimal to ASCII code and display on LCD. Int, x1 x2, x3. Define variables. Value equals value multiply by 100. Convert into data. x1 equals value divide by 10,000. And take reminder with 10. Gets 100 digit and copy into x1. x2 equals value divide by 1000. And take reminder with 10. Gets 10's digit and copy into x2. x3 equals value divide by 100. And take reminder with 10. LCD_CMD. 0xC4. Move cursor line number 2 and position number 4. LCD_data. x1 plus 0, this line convert binary code decimal into ASCII code, and print on LCD. Convert into ASCII and print x1 data on LCD. LCD_data. x2 plus 0, convert into ASCII and print x2 data on LCD. LCD_data. x3 plus 0, convert into ASCII and print x3 data on LCD. LCD data 0xDF. Print degree sign on LCD. 0xDF is code of degree sign. LCD data C. Print C on LCD. Int ADC, volt, temp. Define variables. Void, main. Main function. TRISB equals 0x00. Set port B as output port. TRISC.RC0 equals 0. Set port C pin RC0 as output pin. TRISC.RC1 equals 0. Set port C pin RC1 as output pin. TRISC.RC2 equals 0. Set port C pin RC2 as output pin. ADCON 0 equals 0B01000001. ADCON and FOSC over 16 is selected. ADCON 1 equals 0B11000000. Internal reference voltage is selected. LCD INI. Call LCD initialization. MS delay 200. Call MS delay. LCD string, temperature. Call LCD string function and write temperature on LCD. While 1. ADC equals ADC read 4, read ADC values. Get data from ADC read and save result in ADC. Volt equals ADC multiply with 4.88281. Convert into the voltage. Temp equals volt divide by 10. Get the temperature values and copy into temp. Convert display temp. Call convert display, convert ADC data into temperature and display on LCD. MS delay 254. Delay between next cycles. Now we will create the hex file. Just click on the build icon. Finished successfully. File is created. Now we will load hex file into the microcontroller. Double click on the microcontroller. Select the hex file. OK. And click on the run simulation. Now LCD show temperature on it. If we increase the temperature on LM35, then temperature increase on LCD. And if we decrease the temperature on LM35, then temperature decrease on LCD. If you have any problem with the code, let me know in comments. Thanks for watching. Please subscribe to the Star Technology 5G. And keep watching Star Technology 5G.